Welcome to part 3 of the course regarding the development of an interactive car showroom. Within our previous video, we have set up the Unity project that makes use of the SteamVR package. Now I will connect the Valve Index head mount display, and I will replay the default project scene to inspect the existing elements within the package. We are going to see a notification in the bottom right corner that SteamVR isn't set as the default OpenXR runtime. We can ignore that for now as Unity will be connected to the VR headset. After I position the head mount display on my head, I will grab the two controllers. Within the virtual environment, we are going to see that the controllers are identified by the package, and we are going to see the Valve Index specific controllers within the viewport. We can teleport either using the trackpad, indicated by the user interface, or using the joystick on either of the two controllers. We are going to define the target of the teleportation feature, and our virtual camera will be relocated towards that area. We can also turn our viewport left and right using the joystick. Grabbing objects can be done naturally using the index controller. We just need to position the hand over the desired object. This will be highlighted in yellow, and we can squeeze the controller to grab the object. To control the RC car, we need to use the joystick to control the steering, and we are going to press the top button on the controller, which is colored in green on the remote. Since we have two controllers, we can grab the RC car with one hand, while holding the controller within the other hand. The RC car has a front-wheel drive. We can go into reverse by moving the joystick towards us while pressing on the green acceleration button. The car undercarriage is not very high detail as the car has been intended to be used most of the time with the car on the ground. As we see, the car has collision with the flowers position within the scene. If the car is driven beyond the ground floor boundary, we are going to see that this will fall down to the secondary ground floor of the scene. This is an area that by default is unreachable by the user as teleportation is not active on that area. But the RC car and other objects have no restrictions. Next, we are going to inspect the box-shaped character. This is very similar to the RC car. The only difference is that the character can jump when the trigger button is pressed. The character has collision with other elements within the scene, such as the tables and the ground floor. We are going to see within a following video how we can modify the collision meshes to improve the interactions between objects. Now I will grab both controllers, and as we can see, these make use of a script that will automatically return them to their initial position. It is very useful within VR environment that elements that are no longer used return to their default location. As for the car, we can only bring that back with the scene reset. Next, we are going to inspect the hints layout panel. We can enable button hints, text hints, or disable hints. We can animate the hand with or without the controller, depending on the preferred style. There are 4 existing hand models. We can enable the thicker gray hands, or the default red ones, or we can enable the alien 3-finger hands, or the alien floppy hands. I will stick with the default red gloves. We can also choose to show or hide the controller. The 3D model of the controller will match and overlap the position of the real one within your hands, as it is tracked by the base station and the headset. Now let's grab some simple objects within the scene. The objects on the left table will not pass through other objects while they are within the user hands. As we can see, the cubes will have a cube-shaped collision mesh, while the spheres will make use of a sphere collision mesh. This enables accurate interaction between the objects while making use of simple primitive meshes. The objects on this table will behave differently. They will pass through other static objects while they are within the user hands. Let's see how the cubes will interact if I try to stack 5 cubes. The objects make use of rigid body component defined within Unity to simulate gravity. We can further change the parameters of each object to change its behavior. The following elements make use of a throw script. The one on the left are defined differently to match the velocity of the throw to find the peak speed when the object is thrown. The ones on the right will behave different. On their release, their velocity will be calculated based on the previous 3 frames. Overall, the two throw mechanisms are quite similar. To better visualize the difference, we can change the various parameters within the thrown script to better highlight the differences. The following template will indicate what is the hand that is hovering above the sphere, and if it's hovering or not. If the user will grab the sphere, a timer will start indicating the amount of time in which the object has been picked up. As we can see, the following teleporting point is not active. As I am standing to close, I will teleport further away, and then teleport within the following template panel. Here we have a stress ball that we can grab. Depending on the amount of force the user input to the controller is called grip force, which is specific to the index the ball with behave differently. If you are using an older VR headset such as HTC Vive Pro or Vive Cosmos, you can only grab the stress ball as we have previously using the mouse and keyboard layout within the previous video. There are 2 other interactable props on the table, a smile face sphere that we can pinch between our fingers, and a grenade. The grenade will detonate and spawn colored flowers within the environment. Next, we have a linear drive setup that will transform a linear movement into a helicoidal path movement of a sphere. The following object will be a circular drive that we can grab and rotate either to the left or right. The next one will be a button. When the button is pressed, the top cube will collision with the bottom element. To indicate the button press, there is a script enabled that will spawn a flower. Each button press will spawn an additional flower. The flowers are interactable. We are going to use this button to define the interaction within our car showroom project. Next, we have a bow. This is the bow that Steam used within their VR application entitled The Lab, which was released in 2016 along with HTC Vive. The active hand used to pick up the bow will keep the bow, while within the other hand an arrow will appear. Now by default, this is not paired with the Valve Index controller. As we can see, we can position the arrow within the bow. But the trigger button will not enable us to engage the bow in order to shoot. We can change this within the key bindings to enable its functionality. This works by default with legacy VR headsets such as HTC Vive Pro or Vive Cosmos. This was an overview of the prefabs that are available within the SteamVR package. Within the following video, we are going to transfer models from Blender to our project. If you enjoy this content, consider to leave me a comment and subscribe for more. That's it for now. See you in part 4.